using Python?
Yes, yes, yes. Okay, so why do we use Python is a more important question. Okay, so his question was, is there any way to work around using Python? Now the answer to that is, why do we use Python? Machine learning is about the data and nothing else. Python and some other languages from the very beginning were optimized to handle data. JavaScript was not optimized to handle data. When you train, you frequently have to deal with massive amounts of data. Now, in the examples that I showed, that's actually for handling what we call classroom data. Well, classroom data might be a few 100,000 lines of text in a CSV file, for instance. A lot of the time, they're even files that Excel can't open conveniently, because once you get to 1 million lines, Excel doesn't deal with those things. Now, as JavaScript developers, we're not used to dealing with data, or at least not data in that manner, right? So you're used to the classical JSON objects, you create an array, but how many arrays do you hold in memory, right? Because typically, if you use a node backend, you're typically just going to connect to a database and pass things through to the database. You don't hold things in memory. When you do machine learning, you don't just read data, but you need to read data, you need to process data. When you read data in, the first thing we do is we typically create something called a data frame. And a data frame is like an Excel table, but it's massive, right? But it still has its own constraints. So, but you need to hold it in that table, and then start doing things. And things are, for instance, drop these columns, look for null values, replace null values. Those are things that JavaScript is not optimized for. So it's not the language for the sake of the language, there's the why. And even Python has its limits. So at a certain point, when you start dealing with a certain number of records, 50 million records, 100 million records, you then move it into some other thing, like Spark or Apache Beam or something else. So those are all advanced topics, right? So at that point, you can't even mention JavaScript in this statement. Now, what JavaScript can be used for is these last parts where we said, make use of the model. You can actually export that model for use in JavaScript. JavaScript can then import and just do the inference, right? But not train on massive amounts of data. Because one of the reasons why you have that train and evaluate step is that you push that training onto a cluster. And so Google Cloud Platform will take care of provisioning the computers that will handle all of that training for you. And I'm not aware that you can do that from JavaScript. And the secret even is that for certain types of models, they don't even get implemented in Python, they get implemented in C or Python, which is the faster version of Python. Yeah, so it's, a lot of the libraries are written in C, C++, and then they do conversion. So one of the things we didn't talk about, because we didn't need to, because we're talking at a high level, is you actually deal with static graphs. So those static graphs, what happens is they compile into something else. Typically that's C++.
Okay.
Yeah.
So so I noticed that you were talking about Apache Beam and all of that. So that means that you could do, is it like you're doing batch processing before you work with the model?
So you're doing typically transformations, feature engineering, things like, say, take an address and try and extract something from it. Do things like binning, like look at people's ages and put them into categories like, is this a child, is this a teenager, is this an elderly person, things like that. Not labeling, engineering. Yeah. So you do all of that before your model. Your model consumes data, but depending on the volume of data, you might not be able to at once. Yeah, so you can pass it to Beam. Beam can do the transformations and store it in some other files, and then you can pick up those files and do your trading.
Okay, that means that it's not possible to have like a string, like the way you normally do like normal
Like IoT type thing.
Yeah.
You can stream. We have Windows. We can process streaming data, but you window them. So you'd always take a slice. You'd always say, I want a chunk from this time frame. But the thing with machine learning is you go over data lots and lots of time. So you don't typically introduce new data in the middle of training, but you can have this supply and just say, give me data up to yesterday. Now he knows what yesterday is once you start trading. And then if you start trading next week without changing the code, once you say give me data up to yesterday, it knows where to stop.
Okay, I guess that means that before training, you are already on your future engineering.
Yes, sir. I came across a clip, and the guy was talking about machine learning in reference to quantum content,
Okay.
flying information. Can you shed some light on that?
Yeah, so typically that would have to do with maybe path planning for the flight routes or something. But they build a model that detects, say, obstacles, and then you can generate a flight plan based on saying, we're going from A to B, there's a building somewhere, there's a tree somewhere, there's this, there's that, and then you can estimate the elevation of those buildings, and then say, okay, so based on all of the obstacles, in between A and B, this is what our flight plan is, and then just distribute the flight plan to the quadcopters, and then you can get information. It's the same thing that happens with self-driving cars.
So, are you saying if the information given, let's say the obstacle was not initially there, and it was introduced after the flight plan has been given, distributed to the machines, they will still overcome the obstacle?
Well, if they're properly trained. So when you look at things from the end, it's easy to say yes or no, but the real answer from an engineering perspective is if they're properly trained, right? So take an electric iron for instance, that just has, you set it to say, I want, this is nylon, this is cotton, this is something else. But what's happening in the back is that you're saying, if this thing is set to nylon, do not exceed this temperature, and if it is set to this other thing, do not exceed this temperature, right? Now, if you don't set it correctly from the back, even when you twist the knob in front, you're not going to get the desired result. So it's fine to look at the end result and say, yes, you can do this, but it's important to say, you need to have a properly trained model. So you need to have a model that, even when you assign a flight plan or a flight path, you have cameras, and then what are the cameras sensing? And then are you translating or interpreting whatever they're sending to you correctly or not? That's the more important question. All right, any more questions? Okay, thank you.